Okay, let's finish our work on these notes. We're going to apply what we've done in our review and our work on the last page. We're going to apply these to quadrilaterals now to determine if we have a special quadrilateral. We're going to be studying this more next week as well, but this is just an introduction for us. So I have three different shapes here we're going to look at. We're going to do the same procedure. We're going to determine the properties that exist in these quadrilaterals. For each side in the quadrilateral, show the length and the slope, and is it special? Is it a special quadrilateral? So let's start with ABCD. This is quadrilateral ABCD, and you name it in the order of the letters. You could go backwards, and you could call it ADCB, but you can't call it ACDB. You can't crisscross. Anyway, so for quadrilateral ABCD, let's see what we have. Now, I'm going to just use my grid to figure out my slopes here. So I'll just start here. The slope here is down 3 over 1. So minus 3 over 1. The slope here is up 1 over 3. The slope on this side is what? Down 3 over 1. So negative 3 over 1. And the slope on this side, up 1 over 3. Should make sense. These going upward have positive slopes. These two pieces going downward have negative slopes. And it actually turns out that we have some slopes in common. So these two slopes are alike. So we have AD and BC are parallel. And these two slopes are alike. So we know that AB and DC are also parallel. And also about slopes, we can look for opposite reciprocal slopes to see if we have perpendicular lines. And actually we have a bunch of those. So these are opposite reciprocals. So that means AD and DC are perpendicular. These are opposite reciprocals, so DC is perpendicular to BC. These are opposite reciprocals, so we have AB is perpendicular to BC. And then these last two are also opposite reciprocal slopes, so we have AB perpendicular to AD. Now, when you have perpendicular lines, you could also put in these corners right angles, right? Because perpendicular lines create right angles. So basically we have a shape with opposite sides are parallel, and we have 4 right angles. So already I know, I think this would be a square. I guess it could be a rhombus or a square. But square would be the most specific thing. I need to make sure that the side lengths are the same. I'm pretty sure that they are here. Let's look at the side lengths. I'm going to look at, if I just build a triangle here, I know I have a side of 1 and a side of 3. So let's see, AB would be, remember, take the difference in the y values, which is 1, square it. Difference in the x values, which is 3, square it. And I get the square root of 1 plus 9, or the square root of 10. I'm going to just leave it like that. If I look at my other sides, do my little triangles here, that's the side of 1 and 3. That's going to have the same length. Do my other triangle here, side of 1 and 3, same length. Actually, using what you know from the slopes too, you can see that the sides are the same, 1 and 3 here. So all of these little external triangles that I've sketched out are all exactly the same. So they're going to have the same hypotenuse. That means that AB has to be congruent to BC, which is congruent to AD, which is congruent to DC. So we have opposite sides are parallel. Adjacent segments are perpendicular, so we have 4 right angles. And all 4 sides have the same length. So this is a square. Alright, we're going to do the same thing with the rest of these shapes. Alright, if we look at the next one, I'm going to do the slopes first. The slope here is, let's see, down 1 and over 1, 2, 3, 4, 5, 6, 7. Slope here is down 1, 2, 3, 4, 5, 6, 7, and over 0. So if you remember, this is undefined, vertical. So those are not, definitely not perpendicular. This slope here, we're going to go down 1 and over 1, 2, 3, 4, 5, 6, 7, 8. So those looked like they were going to be parallel, but they're not. They're close, but they're not. It would have to be exact. Let's take a look at this one. We've got 1, 2, 3, 4, 5, 6, 7, up 7, and over 1. It has a slope of 7. So if we compare slopes here, and this would be, I'm going to label this quadrilateral EFGH. I have all my different slopes there. The only thing that we know, there's nothing parallel, and these two are perpendicular because they have opposite reciprocal slopes. So we have EH is perpendicular to EF. So already I know it's not even a parallelogram because there's not opposite sides parallel. So it can't be a special quadrilateral that we've studied already. But let's go ahead and look at the side lengths. And actually, if I look at the slope numbers, that basically gives me the 2 dimensions on my right triangle. This would be 1 and 8. These don't have any dimensions, so this is just a vertical line with a height of 7. That's the easy one. And then these have 2 triangles that have dimensions 1 and 7. So these 2 hypotenuse measures are going to be the same. So let's do this. EH is going to be congruent to EF, and let's see what it's equal to. Square root of the difference. It actually doesn't matter if you do the difference in the y's or the difference in the x's first or second. I'm just going to go ahead and use this one. The difference in the y values is 7. We're going to square it. Difference in the x values is 1. I'm going to square it. So I get the square root of 49 plus 1, or the square root of 50. That's going to be the same as if I had done it this way. This way, the difference in the y values is 1. Square it. Difference in the x values is 7. Square it. So even though it's in a different order, the value is exactly the same. So those are congruent, and they have a length of square root of 50. Let's look at GH. The distance here, I'm using 8 and 1, so I have 8 squared plus 1 squared. And that's 64 plus 1, or square root of 65. Obviously, those are not equal. And then FG has a length of 7. Technically, we're not supposed to show this segment symbol with the equal sign. You're supposed to use segment symbols with the congruence. We're measuring the distance, so actually the length of segment GH is equal square root of 65. The length of segment FG is equal 7, but it's close enough. We're not going to worry about that technicality. So this quadrilateral, nothing special. Okay, let's look at the last one, and I can visually see that it's a square. Oh, it's not a square. I thought it was a square by looking at it. I can see that I have right angles here. Let's go ahead and do the work. Quadrilateral here, IJKL. And I have horizontal and vertical lines here. Let's do the slopes first. The slope of this horizontal line, the rise here, or the y value change, is 0. So this is 0 over 1, 2, 3, 4, 5. which is 0. This one is, again, 0 over 5, which has a slope of 0. So those are parallel lines, or parallel segments. IJ is parallel to LK. They have the same slope of 0. They're both horizontal. Let's look at these other two. The slope here, the change in the y is 4. Change in x is 0. This is undefined. Abbreviation UND is common there. This one has a y value change of 4. X value change is 0. This one is also undefined. Those slopes are both undefined, so those are also parallel lines. They're both vertical. So let's write that out. IL is parallel to JK. So we have a shape that has opposite sides that are parallel. That by itself is a definition of a parallelogram. So we know it's at least that type of special quadrilateral, but as we're going to discover, it's even more special than that. If we think about if we have any perpendicular lines, an undefined slope and a 0 slope are perpendicular. That's a vertical line and a horizontal line. Those are perpendicular. So basically I could write a bunch of these. IJ is perpendicular to IL. IJ is perpendicular also to JK. And let's see, IL is perpendicular to LK. And JK is perpendicular to LK. So all these are perpendicular, which means we have 4 right angles. I'm going to draw that in my picture. And so it's looking like this could be a rectangle, maybe a square. So, but right now, the best we can do is call it a rectangle. Let's measure the side lengths now. And this one, we don't need the distance formula, yay, because it's all horizontal and vertical. So this, we can actually already see from our slope work, these two sides are equal to 4. These two sides are equal to 5. So IL is congruent to JK, and it's equal to 4. IJ is congruent to LK, and its length is equal to 5. So we have opposite sides are parallel and congruent. All 4 sides are not congruent, so it's not a square, it is only a rectangle. Opposite sides are congruent. So we had a parallelogram, 4 right angles, opposite sides are congruent, makes it a rectangle. Alright, so that's how I want you to do these problems. Your homework is to do problems 5 and 6 from the packet. It'd be just like my last 2 sets of examples. Part 4, your turn. Problem 5 is to look at the slopes and lengths of those. Determine if any are parallel, perpendicular, or same length. And then apply that to these new quadrilaterals. Same kind of thing. Look at the slopes, look at the side lengths, and decide if they are a special type of parallelogram or a special type of quadrilateral in any way. Alright? Thanks, guys. Have a good day.